So let's get on with the show. So our next engineer is a maintainer of Sentry's open source error and performance monitoring JavaScript SDKs. I don't know if his mouth is as dirty as the ads was. We'll find out shortly. When he's not debugging performance problems or practicing the dark arts of monkey patching, you can find him diving into fantasy novels or playing armchair NBA Team GM. Please welcome Abhijeet Prasad.
Thanks, everybody. What an introduction. Today, I'd like to talk about a topic that maybe hasn't affected everybody working in web development, but has definitely affected some of you, which is publishing a JavaScript library that people can use without it horribly breaking their applications. So I actually deal with this on a day-to-day basis. As mentioned, I work at Sentry. I help maintain Sentry's JavaScript SDKs, completely open source. So actually, all my work is out there for anybody to review also. And we do a lot of JavaScript stuff at Sentry, because there are a lot of JavaScript developers that need their applications monitored. We have over 20 JavaScript-related SDKs. This is just a brief list. There are things that exist outside of our monorepo related to like Electron and React Native. And it's a lot of surface area and a lot of lessons we've learned on how to effectively build packages that people can use. And I want to share some of those lessons with you today. Now, you might be thinking actually like, hey, publishing a package should be pretty easy. And before I started maintaining the SDK, I thought so too, right? Maybe here's like a quick guide. You make sure, hey, you pick a cool name, something that people will like. You have your collection of JavaScript files, your modules for the features that you build. You create a package.json, point it there, give it the name, use npm CLI to publish your package, and there, you're good to go. Unfortunately, not always the case. It's this step that gets really complicated, the package.json, and actually pointing it to some working JavaScript. That can mess up in a lot of different ways. It's really hard to publish robust and extensible libraries, especially with how wide the JavaScript ecosystem here is today. This is a tweet by Mark Erickson. Highly recommend you follow him on Twitter. He helps maintain Redux and Redux Toolkit. And he went down a little bit of a rant of all these things you have to think about. And there is a lot to think about. It's because the JavaScript landscape is so big. There's all these browsers to think about, frameworks. Some use compilers, so specific components like Svelte or Vue. And now we have all these different JavaScript runtimes. So it's not just the browser and Node, but things like Dino and Bun and Vercel Edge. And I keep going and going and going. That large surface area means that the way things can go wrong gets complicated. You got multiple runtimes, JSX, TypeScript. You have to worry about tree shaking. Does it work with every bundler? My God, Webpack 4 keeps breaking. And that's just the code itself. You still have to kind of think about how you do licensing and versioning and all of this. So let's take a look. At least try to fix some of these problems by diving deep into why they're problems in the first place. I'm going to start off by looking at different JS runtimes and how they'll impact how you kind of package and release your applications. Take a look at bundling and bundlers. We'll hit TypeScript, which is more and more important, and do a brief review of stuff around like package health, like licensing and versioning. A lot of this is high level, but hopefully it's good enough for you guys to get interested in this stuff and maybe dive deeper into the material later on. So JavaScript runtimes. What do you have to think about if you want to publish a package? Well, let's start off in the most common runtime, which is the browser. Hey, I'm just trying to write some library that could be used when running Chrome or Safari. My biggest thing here is, if you're publishing a package, make it very clear about what you're supporting. And don't just say, hey, I'm going to pick the last 6 versions of Chrome or the last 6 versions of Firefox, because that's a moving target and might not be necessarily relative to when you actually publish your package. Instead, be clear about your JavaScript version requirement. Say, hey, I support ES6, all the browsers that have that functionality, or ES 2020, or hey, I support everything, but I also need decorators because decorators are cool. I don't know. If you do any kind of transformation, Let's say you're adding your own polyfills, or you're kind of making transforms so that it works for ES 2020 or something like that. Please, please, please add source maps, which basically both browsers and developer tools can use to do a transform between the original source code and however you decided to transform it. This is really useful. Try defaulting to outputting ESM. I'll go into a bit about what that means. And last two things, only publish what people who are using the library really need. Explicitly state kind of the files that you're exporting with files or npm ignore or a combination of both. And don't bundle dependencies that are not required. So a common one I see a lot is like, hey, I'm writing a React component library, or here's a React dropdown you can use, and it bundles React. And then it ends up conflicting with the user's version of React, and you've just caused a mess for them. Let's look at some examples, though, of how this is done. So I'm looking at unpackage, which is kind of like a CDN that mirrors whatever you publish onto NPM. And I'm actually looking at Redux, which Mark Erickson maintains, because it's a really great example of this. They kind of have like this ESM file that kind of has all the code. And they also actually have a minified bundled version that they also export. And this is really useful because there's a lot of freedom. Users can either consume this directly and just put it into a script tag, or they can consume this, which can be tree shaken and all of that. This is a Sentry package called tracing. And if you actually notice here, among all this other kind of boilerplate up here, is that we actually have something called side effects, which is also really important to add about your package. This essentially tells the consumer, whether that's a runtime or a bundler, what packages have side effects and what modules have side effects and what don't, so that they can be tree shaken. For stuff that's targeted toward the browser, really important, because if something has side effects, the bundler is almost always going to keep it, thinking about something like your console log or you mutating some global variable. And that might mean that there's just code that runs but doesn't really do anything. It's excess bytes, it's increased bundle size. So be explicit about your side effects. Now, if you actually also look at how we bundle at Sentry, you can see that we have individual files for kind of every module we have. If you look at something like React, though, they actually have modules for kind of entire bundles. You saw Redux had a combination of both, and you see React only does bundling, and you see we have individual modules. Well, what's right? As usual with everything, it really depends. It's better for tree shaking if you keep individual files, because you can explicitly tell both the package.json and your users which files and modules have side effects versus not. But it's really nice for UX reasons, and sometimes often super easier for bundlers and for users to handle, to have pre-bundled and pre-minified files. I'm not saying either one is better. We decided to stick with the individual files, but pick whichever one after seeing what works. Now, there are other runtimes that are not just the browser, and increasingly getting popular because people really like JavaScript. They want to write it everywhere. In particular, there's a ton of competing server runtimes. Node was the original big one, but there's Dino and Cloudflare and Bun. And there's also runtimes for desktop or mobile, and even embedded runtimes. Some of these do follow a common spec. This is called WinterCG. It's a consortium that was formed by some of these runtime maintainers. But not everybody follows the rules, and sometimes they're broken pretty badly. If you require something runtime specific for your package to work efficiently, a specific API or a specific behavior, be explicit about it. Better yet, if they try to do something in a runtime that's not supported, break horribly. So then they know what's wrong, and they know, hey, please don't use this. Otherwise, the same rules around bundling and files and tree shaking all apply, except maybe not the rule about defaulting to ESM versus CJS. Now, many of you might have kind of heard about this, especially if you're familiar with JavaScript development. There's actually two different types of module strategies in JavaScript land, two different mechanisms, and they cause a lot of fights. Probably see it all over Twitter. The first one is ESM, which it looks like the stuff over here. It's the import and export syntax. This is typically what bundlers supported. So as you were writing code that targeted just the browser, you would kind of use this. Node, on the other hand, had CommonJS first, which was their way, kind of proprietary, but later standardized, for Node with this require and module exports. Later on, when ES6 rolled around, ECMA, the organization, decided to standardize ES modules, what the bundlers had been using, but changing it slightly. And now Node also supports ESM. To enable ESM for Node, you can either change your whole package to say it's ESM only, or use a file extension to explicitly state what modules are ESM or CJS. The problem here is that ESM and CJS have incompatibilities. You can't really use ESM and CJS. Well, you can, but you have to use an import function, and they have different behaviors because ESM imports are async, and CJS ones are sync. And this is conflicting and oftentimes really confusing. ESM was also only for Node 12, which nobody really should be using, but people definitely do. In fact, the Sentry SDKs support Node 8+, just because people really don't like upgrading their Node version. CJS doesn't work at all in browsers. It was a Node-specific thing. Some bundlers do accept CJS and then transpile it and bundle it to something that the browsers can understand. And the big thing that why Sentry still has CJS stuff that we produce, even though everybody says, hey, use ESM, publish an ESM, is that ESM doesn't support monkey patching. There does exist loaders, but this doesn't really work one-to-one as the same CJS behavior. And so if you're trying to instrument a library by wrapping it to catch errors or performance data, like we rely on, doesn't really work with ESM. So what's the solution here? Well, just publish both. Have a set of JavaScript modules, have some bundling and transformation process, and end up with both an ESM set of files, preferably with the ESM file extension, and a set of CJS files. You have to take some care because there's something called a dual module hazard, which you could probably write like an entire thesis on. But the gist of it is that if you publish both, users might accidentally use both, and then there's an ESM version of your package and a CJS version of your package floating around in Node modules world, and it sucks. But generally, emitting both is a good strategy to maximize backwards compatibility and make sure as many people as possible can use your library. Unfortunately, things get a little more complicated when types are involved. TypeScript. It's the way most people are actually writing JavaScript nowadays with types. But how TypeScript works is that it has kind of a syntax that sits on top, and then you use some kind of compilation or transpilation layer to turn it into JavaScript. TypeScript relies on things being typed to give you maximum information about how it should be used and what it expects for that kind of type safety. And so then there's that kind of open question of like, hey, should my library support TypeScript or help with it? If you ask me, my overwhelming opinion is that yes, because TypeScript really, really helps the developer experience of the library that you produce. People don't have to kind of look up docs. They can look up the types and how your methods should be used right in the editor, and you get super nice autocomplete in kind of modern IDEs like Visual Studio Code or WebStorm. You have two options for kind of getting types to your users, telling users how the types should look like for your library. You can write your code in TypeScript yourself and just have that there. Or you can just write JavaScript with JSDoc, which is a library that allows you to kind of write comments that look like this, that basically can be then turned into types. You'll notice here in this comment there's actually no type comments because this is actually just a screenshot from the Sentry SDK. We use TypeScript and JSDoc. We use both, but we just rely on TypeScript for the types and not JSDoc for it. This does mean, though, that alongside your ESM and maybe your CJS for this kind of final distribution of your JavaScript, you also have to publish your types. You can choose where, though. If you're publishing your TypeScript types, I heavily recommend just publishing it with your library itself. It's super easy. Everything's in the same place. You can make changes. Breaking changes are easier. Just less friction. But not everybody wants to do that. And so there's also an option to use definitely typed, which is an external repository that is contributed to by the TypeScript team. And you can just store type definitions for your library in there also. One thing, though, is in both definitely typed and with your library, if you're publishing your types, don't just publish your raw TypeScript. Publish the declaration files, because this ensures maximum compatibility with all the bundlers, TypeScript versions, and it's also way faster. If someone has to parse your TypeScript declaration file, it's way easier than having to parse a TypeScript file and deal with a lot of the nonsense that JavaScript brings. There's a really useful tool written by Andrew Branch, who works at Microsoft on TypeScript, called Are the Types Wrong? He actually, I think, wants to revamp this website, so maybe this link changes in a week or two. But this is really useful to know, hey, did I emit things correctly? Another thing to note when you're publishing your types is that you might actually want to down-level your type. TypeScript does not follow semantic versioning. So if you're on TypeScript 3.6 and you bump to 3.9, there could be breaking changes in between there. And that means that people often, for their own libraries and their own applications, stick to a specific version of TypeScript because it's safe. You know, bumping TypeScript might be dangerous, and then they lose a week to try to fix out all the bugs. If your library relies on a specific TypeScript version and it emits types, it might be incompatible. Let's say I build my library with TypeScript version 4, and someone relies on TypeScript 3.8, or actually, let's say like 3.5, and my library uses something like tuple types, which was introduced. That just breaks completely, and the types don't work. And now your user's completely stuck. There's a useful tool for downloading your TypeScript. You can add kind of logic to your package.json that looks something like this. That basically says that, like, hey, this is the modern TypeScript types with the most recent version. And then we down-level it so that it's compatible with your TypeScript version. I don't see a ton of people doing this, and I heavily recommend, if you want to maximize compatibility of your library, you should. So with that in mind, kind of a standard setup looks something like this. This is kind of what they call, this is in your package.json file. This is what they call the export syntax. It's what's official. Before this existed, because again, JavaScript is so big, a huge moving target, it's been around forever, there was these things for main and module. These are pseudo-standard. For example, with like module, it only really supported by bundlers. Node doesn't care about it at all. But usually, you stick these on so that people who use like Webpack 4 just doesn't randomly break. With the exports, again, you're emitting two different sets of files, one for your ESM code and one for your CJS. And again, you're explicitly only making sure that kind of what is required by users is exported by your library. You'll also notice here that the type declarations are also ESM, and in this case, there's no CTS, but you can add it if you want, CJS specific. And that's because just like how ESM and CJS are kind of incompatible in some ways, so are their TypeScript declarations. So you must have separate declarations if you're emitting both, unfortunately. That's a lot, and it can even be complicated to set up a build system to emit all of that. So I would really recommend just not worrying about too much of it and using a tool like Unbuild. You can also look through their source code, because it's completely open source, to understand the fundamentals of how these things are emitted in case you want to handwrite something yourself. Unbuild generates ESM and CJS and the types and puts them in the right place, and also will check for you if all your exports with subpaths and conditionals are set up correctly. So let's actually take a look at a library that uses unbuild. The Sentry SDK doesn't because we hand wrote all of our rollup config to make this work. Because unbuild didn't exist back when we did this, we just kind of had to solve the problem ourselves. So this is million.js. Maybe some of you have heard it. It's kind of like an alternative virtual DOM runtime for React that you can kind of drop in, tries to make React faster. And if we look at their package.json, you can see here that they got the main module types and some other stuff that I don't think that's needed. But you can see here they have all the exports set up. In Million, and this is supported by most bundlers and most Node versions, they also have for subpath exports. So if it's not, you can just not only export from a package, but also from package/foo or package/bar. And you can see here it all points to its individual ESM and CJS files. But actually, even though Million uses unbuild and is set up really well, if you feed it into are the types wrong, there's actually a problem with masquerading as CJS. And so things are not as simple as just using unbuild. You have to still go in and debug things yourself. My #1 recommendation for these things here is to go in and see the generated JavaScript, read through it, and have an understanding of, I had my original source code, how did it transform into whatever I'm giving my users? This is also helpful for other reasons, like improving your performance and generally just understanding how things are being sent. I actually have a whole blog post on this on the Sentry site, where I go into kind of performance optimizations by looking at generated JavaScript, if anybody's interested. And if you're curious at Sentry, for our types wrong, we have a way simpler kind of setup because we have a bunch of different NPM packages for like React and Vue and Node and so on. Things are split by runtime, split by framework, so we don't really have all of this to deal with. So yeah, everything works, for now at least. So that's kind of setting up ESM and CJS, setting up your TypeScript types. But there are other things to think about when you're publishing your libraries. Please, please, please decide on a versioning scheme. It doesn't have to be what most people and what NPM traditionally parses with major, minor, patch. You can be like TypeScript and choose not to follow semvar with this strategy. Just decide on a versioning scheme and have a public changelog. This really helps people consume your library and understand how it's meant to be used. You can also easily schedule breaking changes and deprecations this way. There are a ton of libraries. I recommend Semantic Release, but a lot of kind of GitHub Actions, CI tooling that you can use to make this easier. You don't have to manually do it yourself. The last big thing to kind of make sure it works, because it's really important whether you're kind of distributing a software library of any kind, not just a JavaScript package, is make sure you have docs and make sure you have licensing. If you're open sourcing something, always add a license. Something like choose a license can help a lot with this. And just pick whichever one feels best to you. You're writing the library, you're maintaining it, so you can call the shots. In addition, clear READMEs and contributing docs can help with contributors. But if you use JSDoc and TypeScript, aside from having types, you can actually auto-generate docs from those types, avoiding you have to duplicate that and write the docs yourself again. Really, what I'd like you to take away here is that easy library publishing in the world of JavaScript is all about making your intentions clear. It's about clearly outlining your requirements for your ES version and your runtime. It's about clearly defining how your package is meant to be used, entry points. This is CJS, this is ESM. Talking about if your package has side effects, emitting source maps, and having a good changelog and having good licensing. If you're very explicit about all of this, you'll find that actually most of the problems that people run into today can be solved pretty easily. There's definitely still hurdles. I showed you that million.js example, right? But that's just JavaScript. That's what it takes to support so many different runtimes, so many different browsers, and so many different developers all around the world. So enjoy the ride. Thank you very much. You can find me on Twitter or Blue Sky, but actually where I hang out for most of my day is on GitHub, working on our open source JavaScript SDKs, the fastest way to reach me, actually, is probably to just open a GitHub issue on the JavaScript SDK. It's probably me going to be responding. So yeah, thank you very much. Appreciate it a lot.
I weep for your GitHub notifications after saying
Oh,
that.
it's brutal. And taking vacations can be tough.
All right. So we're just going to get right into it.
Let's do it.
With the need to support ESM, CJS, and even older UMD for browsers, which is the best format to author in while building to the others? And is it really ESM?
So again, it depends. So I would say it's ESM because eventually, at a certain point, we are going to get rid of CJS. It will happen. I don't know if it's happening in the next year, next 5 years, or maybe even next 10 years. But it is going to happen. And so sticking to the more modern syntax that works across all the runtimes, across browser and Node, and any future JavaScript stuff that decides to get invented, future-proofs you. It also means that tooling, think stuff like ESLint or Jest or Prettier, you'll catch up with that because maybe they decide to drop support for CJS before you do. And so writing stuff in ESM means that you can write code that kind of has maximum utility with all your developer tools, and then you can just rely on bundling processes, hacks, whatever it takes to get CJS working.
Gotcha. So kind of on the tail of that, what needs to improve in the current JavaScript ecosystem for us to have a better experience of building and maintaining these libraries?
There's a lot. I think like the biggest thing, and I've ranted about this a lot on GitHub or on Twitter, everywhere, is that like the break between CJS and ESM felt really harsh because they're incompatible, right? Like one works differently. Like making something asynchronous when it was synchronous before is just different behavior. And it surprises a lot of people because they can have a package one day that just works, or like a website or a web server that they built, they put their hard work into, they decide to update one dependency or upgrade a Node version or accidentally flip a command line file or put type module, and it just breaks horribly. And it's really, really hard to understand without all like the nuances and a ton of experience to understand what went wrong. And that's a really frustrating experience, you know, like you can lose hours to this and it feels really bad. So I think like the biggest thing that we need to do, that I think runtime authors, bundler authors, and node maintainers themselves, is to figure out how do we make that transition process more gradual and way easier. A lot of people who work on JavaScript stuff in general don't really pay attention to stack traces. It's something I think about every day because I build an error monitoring SDK. And even just going as far as fixing the stack traces, making it look better, pointing people directly to, hey, you got this error, this is the part of your package.json you have to fix, goes a long way. I don't think a lot of the existing tooling has really built that, which has caused a lot of the frustrations. But it's fixable, you know? Unbuild really helps because they actually also, as they're building, try to point out, hey, you messed up your distribution this way, or this file looks funky, or this package.json part looks weird, which I think is a good first step, but we need to keep taking that.
Got it. If I've got an open source project and I'm trying to get people to contribute to it, what are the, like you talked a little bit about, you know, clear README and things like that, but what other steps should I be taking to try to encourage people to get involved and be part of it?
Yeah, great question. So I think removing the barriers to entry is the easiest way to get other people to start contributing to a library that you built. And so documentation is like probably the biggest part of this, both generating documentation on your public API, how it's meant to be used, as well as contributing docs on how your repo is meant to be run, how it's meant to be tested, kind of maybe some small quirks you have to think about, like, hey, this like file that looks really weird with like this just mess of JavaScript is actually completely intentional because if it's not there, it breaks everything. Another part of this is kind of encouraging forms of discussion. And so you can do this through adding things like issue templates, enabling discussions if you're using something like GitHub. I think there's a GitLab equivalent. And also just opening up a Discord channel. I think like inviting people to kind of join you to talk about your library and the things you built in the channel that they're comfortable in goes a long way. Some smaller things that I've noticed helps a lot is adding a contributing code of conduct, which kind of helps set baseline expectations. It might sometimes chase people away, but I think those are the type of people you don't want actually hanging out in a community you're trying to build.
Yeah, I think generally if a code of conduct is a non-starter for somebody,
Yep.
I didn't want them to hang out anyways.
Yeah, pretty much. But you'll be surprised. We've seen it at Sentry. So, yeah. So I think it's like trying to make kind of things that are welcoming and as easy as possible to understand without necessarily you being there beside them to be running the library or testing it or writing stuff for it is the best way to encourage contributions. And I don't think it's that hard, to be honest. There's a couple of steps involved, but a lot of things just make sense, and it'll be useful for you yourself.
So for those of us who have opted into not just maintaining packages, but who have opted into maintaining packages as part of a monorepo, do you have any advice?
Things will get more complicated because you have to deal with kind of dependencies and interrelationships between the different packages in your monorepos. Another thing to worry about actually is also circular dependencies, which breaks a lot of other stuff too. But generally, the kind of thing to think about is that every package in your monorepo will end up having some distribution of JavaScript that will be published to NPM or to a private registry or to something else. By making sure whatever is there, that distribution works without necessarily needing to worry about the relationship with other packages in your monorepo, you basically take the first step to ensuring that your library works. There are some added complexities, but I think it's always solvable. And there's a ton of really great monorepo tooling out there that helps you with this and will even tell you, hey, you're doing things wrong. So in Sentry, we use a combination of Lerna and NX. It's all, again, open source if you're interested in how it's configured. We also have written a blog post about that. But I've heard great things about Rush, which is out of Microsoft. I've heard great things around TurboRepo. Don't try to roll your own with just relying on pure like NPM or Yarn workspaces. It works to a certain extent, but you'll find you'll hit hurdles. If you try to then hack in caching, things will break. Try to use a monorepo tool. It really, really helps a lot with this stuff.
Sorry, I'm processing some trauma with that one.
Hey, no problem. A lot of these questions are just you think back to 6 months ago, 8 months ago, when I spent weeks on debugging an ESM problem or things like this. It's gotten a lot better since then, by the way. We made a lot of progress, built a lot of tooling. Hopefully this talk also helped. It's a lot of lessons I learned too.
Yeah, I feel like the amount of stress that comes with trying to manage this sort of constantly shifting landscape, I feel like I aged 5 years just watching this talk from the wings. So I think probably the question that all of us have, because you look great, is what's your skincare routine?
I guess I don't know. I don't really have anything super complicated. I don't have anything special. I guess the biggest thing there is that at the beginning, especially when you're I want to write a library that everybody's going to be using, you get so worked up and really into it. You got to, I guess, learn to detach. You have to learn to ignore that this new runtime came. It's not my problem, until then your manager tells you it is, and then you got to do it. But until that point, you can just not worry about it too much because it's also a lot of decisions you have to make is all about surface area, right? How many people am I going to benefit by keeping this compatibility layer or putting in all this effort to make this specific thing work? It's also one of the reasons why I really, really like when libraries like Sentry has a huge node version support radius, even though the LTS is node 18 or node 20. It's actually because a ton of people use node 12 or 14 or 16. Because like upgrading stuff is complicated. And not everybody is has the same level of expertise and the same skills. Like maybe they're like an embedded developer that happens to have just CLI tool. You can't ask them to like upgrade to Node 20 and learn how ESM modules work. Good luck.
Yeah, I think it's easy to, like, as an individual developer, say, look, well, everybody should just upgrade. But I remember working at IBM where a lot of companies, there were so many regulatory hurdles to change software that we had internal forks of our software that were like, this is the current version, but all of these giant corporate companies cannot legally upgrade. So we forked our software to run on the old version so that it doesn't break their. It's not always that developers are being lazy. This stuff is very, very complicated when you get to big old companies.
Yeah, absolutely. And like one more note about that: if you're just making a library that you just want to share with others, remember I get paid for my library work, so I can take the extra steps. You don't have to do that. If you think that like, oh, it's going to be such a hassle to try to support these older versions or to support someone who's like forking actually a library that I depend on and then monkey patching it to make it work. Just say no. It's a very important skill to have for a maintainer to have. Say no, say it a lot. I still say it, even if, again, it'll get me in trouble sometimes. But
So speaking of like extra steps, do you think that it's still worth shipping UMD on top of ESM and CJS?
Generally, I think no, because the latest versions of all the bundlers people use can consume ESM or CJS and use it well, and none of the new kind of runtimes or versions need it. I think everybody's kind of standardized on ESM being the way to go. CJS is just there for like the Node versions, for the bundlers that behave weird, for cases like monkey patching and stuff where ESM just doesn't work as well right now.
Great. So you said you weren't sure, but I'm going to ask you anyways. Knowing that this is conjecture and not a promise on behalf of you to the entire JavaScript community, when do you realistically think that we will be able to ship only ESM?
I don't know. I wish I would know the answer because it would make my life so much more easier. I could just set a deadline, calendar reminder, burn it all to the ground, ESM only. And it's just, there you go. It's like half my distributed JavaScript that people are debugging and using just is solved. I think like a lot of it is going to be based upon what the the big JavaScript dependencies we rely on for our day-to-day, things like Vite, TypeScript, and the runtimes like Node or Bun or Dino decide to do. Like stuff like Dino just decided, hey, CGS sucks completely, it's ESM only, and then they added npm backwards compatibility, Node backwards compatibility as well. And I think it's really up to them and seeing how them to make a decision. It's probably going to be like a big player, like a TypeScript or something, or one of the bundlers that decides, hey, we're just going to rip the Band-Aid and stop the support. That might like start knocking it on the dominoes. But for now, until somebody does that, we're kind of sitting here and waiting.
Gotcha.
Sorry, I know that was a cop-out answer. I didn't.
No, that's a perfectly reasonable answer because there was no way you could have known. I'm just trying to put you on the spot. So I guess we talked a lot about what makes this stuff hard. What do you find most exciting about the space? Like, what improvements have you seen over the last little while that have you feeling like we're moving in the right direction?
So I feel like even though a lot of the changes for modules and that TypeScript is doing related to like bundling and even all the bundlers in general is moving us a lot further in terms of like performance and stability. I'm really excited about a lot of these changes. There's been a ton of great content out there that's all about like speeding up the JavaScript ecosystem with different libraries. Runtimes like Bun have made it kind of their mission to say, let's make things as fast as possible. And a lot of that stuff is powered by ESM or changes that TypeScript is making. And that, I think, is really cool because focusing on performance for all these like lower-level JavaScript libraries we rely on, even something like the Sentry SDK, has massive compounding effects because there's so many users and so many different applications and kind of ways it's being used that I'm really excited about all the new kind of like performance work that's being put in. There's even like a new performance committee for Node that's doing like some amazing work. You can go check them out. Their meeting minutes are even open source if you're interested in kind of the work they're doing. And then, of course, like the stuff that Veet's doing is incredible. Like every release, it seems like they're making something faster or more efficient or more effective.
Yeah, I made a joke about how they've kind of taken over the whole framework space, but it's for a reason. They're doing
I mean, they got everybody
absolutely
but
stellar
Next.js,
work.
so.
Yeah. I think that's all the time we've got. Thank you so much, everybody. Give another round of applause for Abhijeet.